that should be going into full present mode. There we go. All right, so I'm on an ultra wide. How's that look to you guys?
Looks good.
Looking good? Excellent. So let's get started then. This is a brief thing that I put together with one of my colleagues, Marta, who actually I saw join the call. So you can ask her tons of questions later as well. Just kind of starting it off, thank you, Dan, for the wonderful intro. As I said, I'm Ryan Nolette. I've been a security practitioner in various capacities for the last 15 years or so. Most recently, I am the co-author of Amazon AWS Detective. You guys probably saw that get announced at reInvent, and it just went GA. It's for learning to threat hunt and basically respond to incidents faster in the AWS environment. I'm also a published author for threat hunting. The Threat Huntopedia is a free threat hunting guide with a bunch of guest hosts. Everybody gets a chapter. So we have like Richard Bailiff and Danny Akaki and me and a couple other people as well talking about various ways of threat hunting. Then I see at the bottom, my colleague Marta. When we did this, she was a developer at Wazoo, and she was their leading AWS expert as well as one of the programmers for this. So if you guys have some of the programming questions, she is a great resource for that. What we're going to go over in this talk is we're going to go through a practical example of detecting and investigating an attack in the cloud, as well as part of this is we are giving away the detonation lab. So all these screenshots that you see from the live action kind of demo that we're going to walk through, that code is all available on GitHub for free. You can take it, it's a CloudFormation template. You can spin it right up in less than 15 minutes. I think it's 7 minutes. You can go from nothing to a fully configured detonation lab with pre-configured attacks, automated logging for guard duty, VPC flow, CloudTrail, all that stuff. And I'll get into what those are and kind of learn what logging in AWS is like. Kind of, if I poke something here, does it light up over here? That kind of work, and learning how things connect to each other. Hopefully this will help you learn how the different log sources work together, provide a full picture of an event, right? The term full stack analysis, even in the cloud, once we move off-prem, that is something that we want to maintain as part of the incident response lifecycle. So here, we're going to go over the who did what and when, some of the common techniques that we're going to see, common visibility tools, and then we're going to break things into my two favorite categories, visibility and accountability, and we're going to describe how we increase accountability by increasing visibility through technical controls and policy, how to fetch logs from AWS, which is a very unique and time-consuming process until you kind of learn the tips and tricks to it. And then we're going to go through that end-to-end example. So I put the detonation lab on the internet without anything secured, and we let terrible things happen to it. And this is us investigating one of the fun events of compromise that occurred due to putting it on the internet on purpose like that. Then we're going to go over kind of finding what matters, and at the end we going to open it up for questions, both about the process, the different tooling used, AWS technology in general, and I recently just gave a talk to my team on how to do forensic artifact gathering in AWS, so we can talk about different tooling and things as well if you have questions about how to do these types of activities in a cloud environment. This is going to be AWS specific, and that's just because at the time that this was originally written, I worked for them, so I couldn't, use Azure or GCP or any of the other guys. But if you guys are interested in learning how to do it in those cloud services, it might be interesting to do an update to this. So the who did what and when. As any part of investigation, you strive to answer kind of three questions, right? The who, did the what, and the when. This is an iterative process, and it gets repeated for every step in the investigation, right? I should be able to start with the knowledge of any one of the three and work my way back around to find the other two. For example, I start my investigation with an IP address. I have the who. Next, I need to find the time scope of when it was used. That's, the when. Then I find the IP address attempted to SSH into my instance 300 times in 10 minutes. That's the what. So with those three questions answered, I can reliably say that the external attacker tried to brute force SSH access on my instance because I was able to answer the who, did what, and when. And I know that's a very simplistic example, but I want to clearly explain those three tenets because they're going to be important and kind of be a reoccurring theme throughout the rest of the presentation. So some of the common techniques. The common techniques for gaining visibility in your environment are mainly from, pulling logs, from OS hardening, configuration management, identity management, process monitoring, all those different services that you are using in your environment. To expand on the tenets of that investigation that we just went over, we break them into the two buckets: visibility and accountability. And if you cannot see something, you cannot account for it. Therefore, you have to keep increasing visibility until you can account for each event in your environment and answer those three simple questions of who, did what, and when, right? And that's always the end goal, right? It's the next to impossible to actually get there, but it's an iterative process. Security is a journey, not a destination, all those kind of fun phrases. And the reason being is because every day that new technology comes out, we have to figure out, once again, how to answer the three main questions: the who, did what, and when. And those will end up gaining accountability around the activity in your environment. Keep increasing the visibility. You want to know who did it. Well, we need access control for identity management. We need network logs for IP addresses or host names, something along those lines to start building that who, and things like that. How do we get that in AWS? Well, AWS is very similar to on-premises as a technology. So you do it the same way that you would on-prem. The only difference is they're different terms, and that's mostly because these are proprietary to AWS. But the AWS tools, service-wise, are the cloud equivalent of their common on-prem twinsies, shall we call it. And they don't have to be frenemies. They can be best friends, right? If we want to have a simple net flow, we don't need to install bro sensors on all of our instances, though I always suggest having that kind of visibility. That's nice. We don't have to have all of our instances logged into a common single sign-on service or anything along those lines, because we can use VPC flow to monitor the traffic in and out of our VPCs, or virtual private networks. And what we're able to do there is gain visibility to inter VPC traffic, but that's not the only way to interact with AWS resources. AWS is basically a collection of APIs that work together. They're a collection of microservices that intercommunicate through those APIs. So every time you interact with AWS, whether it's through the console or through the Boda 3 client for being programmatic, or the AWS CLI application on Windows or Mac or Linux, what you're doing is you're interacting with the same APIs, and all of those are logged in CloudTrail. So a user logged in, MFA failed, somebody started a new instance, a new user, of those kinds of events, they are all logged in CloudTrail. So that already is giving us a ton of identity management. And if you configure IAM, which here is for identity management, that will allow you to assign unique attributes to those users. So please don't share credentials. It is incredibly easy to share permissions out. And what you're doing is a disservice to yourself when you're trying to figure out who did what and when you can only limit it down to a common account or a service account. And we see it all the time, people that use automated deployment like Puppet and Ansible, is that they're reusing credentials rather than assigning and generating them on the spot and saving them in credential management. well, where there's a lot of built-in tools in AWS on how to deploy and randomly generate that kind of access, or build systems with only SSH key access, so passwordless logins. That is all built in, and it's meant to restrict the ways of logging in to only those that are logged, which is, once again, one of the two tenets. We're gaining visibility to gain accountability. Even though it's not a technical control by who can log in and log out, it's a policy control, and you're restricting all the ways to log into that system that are not going to be logged. Therefore, you're reducing your risk surface, and you're making the auditor a very happy person, and it will not be a resume generating event for you if something goes wrong. Now, the end-to-end example, kind of at a high level, this is where the practical application of what I've said so far kind of comes in. I know that that was a lot of information really fast, but what we're going to do now is we're going to take that fast overview and we're going to break it down kind of step by step into more practical examples, stuff that you would see actual in the wild, in the environment. Nothing you're going to see here is theoretical. All of it is coming directly from either terrible things I have done or terrible things that have happened to me in production, right? So if I start crying, you know exactly why. For this, the scenario here is very common. We have a DevOps engineer. They are under the gun from their boss, right? Their engineer, his only job is to make sure that this new feature gets into production before end of day Friday. That is his only job. If he does not accomplish this, he no longer has a job. Therefore, as a security practitioner, I have to understand that business need inside of the house. Security is not going to be his primary concern with this deployment. Speed and reliability is his primary concern. So he's either going to build a solution himself, or he's going to use something that already exists to cut down on his development time and pushing that to market. So he is not going to look at the security stuff. He's going to find a new tool that they need for monitoring their application or pushing that new feature, and he's not going to check on whether or not that application has something bad in it. In this scenario, the DevOps engineer installs a new application. It happens to be an RPM, which is a Red Hat derivative package manager. So Fedora, Red Hat, CentOS, anything in that kind of distro flavor runs RPMs. And that RPM happens to contain a crypto miner. Now, if anybody has ever run web servers in AWS and kept them alive for more than a couple of days, most likely you have eventually run into a crypto miner because they're sneaky, they toss them in everywhere, and it's probably one of the most prevalent issues in AWS. So the endpoint, it doesn't have any whitelisting software on it, so there's no preventative maintenance. It's a Linux box, so most AV is not robust enough for it. Your EDR clients usually run a list of IOCs, but they do record what's happening on the endpoint, but nothing proactive. So the RPM meets all the conditions for getting installed, and the application gets installed. Now, nothing at this point has set off any red flags, but thankfully, SecOps is vigilant. SecOps records logs. SecOps finds an anomaly, and SecOps starts to defend. So in this case, what we're seeing is we're seeing a spike in outbound traffic to China, and we want to investigate. Now, once again, these are all true stories with the names changed to protect. I'm not going to call them innocent because they totally did that to themselves, but you get the idea. What I did from this is I built a detonation lab. So we're going to use this lab to go through this scenario. The topology of this is pretty basic. There's 4 hosts in it, 3 Linux and 1 Windows, and I have it behind a Bastion host. The only reason I got a Windows host in there for this environment is so you can do some of the pre-canned Windows attacks, as well as see how Windows reacts in the same environment, and how you can collect that logging for full stack analysis. The real bread and butter comes from the the Red Team instance in there, which is pre-configured with a bunch of attacks that are pretty benign, but will set off things like guard duty and IPSs and other common tooling. So if you run this in your environment, you are going to set off alerts, right? It's designed to set off alerts on purpose, but it builds its own VPC and it's only accessible via the Bastion host. Nothing in, nothing out otherwise. Um, the network traffic does go out through the VPC gateway, so it doesn't interact with any existing infrastructure in any way, shape, or form. Just in case you do feel like running it like that, I took those precautions. Um, Here we have a Wazoo server. In this case, if you haven't heard of Wazoo, it's kind of a management suite built around OSSec. It's open source, so it is the best option uh, cost-wise for me to do in a demo lab where I can spin things up because licensing, um, under I think it's under Apache or it's under GNU licensing. Either way. I got permission from them to put it into the lab and make it part of this. As I said, Marta, my colleague's picture that you saw earlier, she was working there and she was actually the engineer that was assigned to work on the integration with me. When I came from AWS and said, hey, I would like to ingest all AWS logs into your product, and I will build it for you if you give me an engineer to help integrate it into your platform. So that's why that's there. You could do the same thing with OS Query and Elasticstack. You could do the same thing with your proprietary EDR vendor. Basically, we're looking for endpoint telemetry. So take whatever vendor you want and put it there and toss it into a SIM. That's the main goal of it. The Wazoo server, like I said, is just going to be collecting telemetry. So each one of these instances has a EDR sensor on it, and it is also collecting AWS logs. So it is grabbing GuardDuty, Macie Inspector, and VPC Flow, CloudTrail, and a couple other things, which I'll show you in a minute on a slide. Then we have the two targets, Windows and Linux. The Linux server is running a vulnerable PHP web server. So you can do server-side request forgery attacks. You can do different injection attacks, whatever floats your boat. The Windows system is just a Windows system running a public RDP port. Please never do that in production as well. So those of you who are running AWS environments, scan it for RDP ports open to the public, and then please restart those systems, like complete refresh, because most likely they're owned. RDP port to the internet is scary. Here's the logging. So like I said, we have IAM logging, which is through CloudTrail, Macie, GuardDuty, things like that. And this is roughly the topology of how things are getting gathered. For GuardDuty and IAM and Macie, what we're doing is we're using a CloudWatch event rule. And if people have questions about that, that could be like a whole discussion on its own for how to set those up. But basically it monitors the event stream. So anytime CloudTrail generates an event, it is getting monitored by the CloudWatch event rule engine. You basically just set a string for it to match on, and then it triggers an event. You can trigger a Lambda function to start. You can use this, what we hear is a Kinesis fire hose, so it collects a lot of traffic at once. You can have it write to an S3 bucket. You can have it send an alert through SNS or SQS, whatever your alerting service is. You can even have it send you an email. Your possibilities are almost endless with that kind of thing. So we use that as kind of the middleman to watch all this traffic because it doesn't cost me more money to use. And with an open source lab that you give away for free, you want to cut costs. So a lot of this tooling is going to be free to use or very cheap to use. The next thing is flow logs. So this lab was originally built when VPC flow logs did not support writing to an S3 bucket. So we had to write VPC flow directly to a fire hose at the time. Now this will write to an S3 bucket. So the process will be the same for VPC flow, CloudTrail, all of my security tooling that's AWS native. All of that will get pulled for on an S3 bucket by Wazoo. Wazoo basically runs a collector and it uses an API key to access and read my S3 bucket by assuming a role that I've generated. If you want to go into identity management, roles and groups and policies and stuff, we can also chat about that later if you have questions. Uh, Basically, I'm assuming a role which has certain permissions to read and write to an S3 bucket. It's going to collect all the logs from there, and it's going to start ingesting them into the Elasticsearch database. One of the other fun things that we learned is Inspector at the time did not support polling or writing to S3 buckets or even working with CloudWatch. So what we had to do is we had to write a custom parser to manually poll that, which will lead us into a discussion in a minute about log formatting and all the trouble that we had to go through to get it standardized, and some of the tips and tricks so that way you guys won't struggle the same way that we did. Going through the logging services, these are all the ones that we included in the detonation lab with a brief summary of what they do. So if I want to automate logging and automate the visibility deployment in my environment, you're going to want to use some of these tools. CloudFormation, like I said, is like Ansible or Puppet or whatever deployment system. You guys might have heard of Terraform. Same idea. Terraform is cloud provider agnostic, where CloudFormation is AWS specific. That's they're simplifying it. There's a lot of other differences, but that's like the big difference for me. S3 is just storage for me. I think of it as a NAS that I have access to. So same thing as your corporate, D drive or Z drive or whatever you guys mount on Windows when you log in. Same kind of idea. VPC flow is the net flow in the environment. So that allows us to track the traffic in between systems as well as in and out of our VPC. IAM is all of our identity management that we're going to be doing. It's the same kind of idea as Active Directory or your Etsy password file in Linux or something along those lines. CloudTrail. This is kind of one of the ones that doesn't have an equivalent. What it's doing in AWS is it's tracking every interaction with AWS and logging things like geolocation, IP address, your timestamps, your user agent, what API call was issued, all that kind of stuff, which makes it a very rich data source for us to mine. I couldn't really think of a good equivalent in an on-prem because it's kind of a culmination of like 3 or 4 sources in a standardized on-prem environment. So it would be like going through your SIM to ask questions. Next up is Macie. Macie, at the time of this writing, is more for classifying sensitive data in S3 buckets. It is eventually going to be more of a DLP solution. So I like keeping that live so I can keep up to date with it. Inspector is a automated scanner. I know that it's going to be more of a vulnerability scanner going forward. So we use it for assessments of some compliance. Now things like Security Hub handle a lot more of the compliance, but originally Inspector did things like CIS baselining and things like that. CloudWatch, as we mentioned, is kind of the monitoring and management service. I use it as my middleman for any time I want to analyze events from a service and alert me based on actions. There's a new thing called CloudWatch Insights, where I can have CloudWatch store the data, and then they do some really fancy ways of like diving into the data and making pretty pictures. When my managers ask me why I did something, I like to use it to make those pretty pictures, and I put them in reports with very few words and lots of the big pictures, and then they keep paying me. So it's working, and I suggest working with it. Last on the list is Guard Duty. Guard Duty is kind of like an IDS. It's not a traditional IDS where that monitors traffic and looks for signatures within the traffic. This is looking for signatures in AWS behavior. So things like credential, metadata exfiltration, SSH brute force attempts, RDP brute force attempts, people scanning access logs or scanning your S3 buckets, things like that. All right, so let's go over a little bit about one of the tools that we're going to be mainly using. Wazoo, um, if you guys haven't heard of it, like I said, it's an OSX, sorry, not OSX, OSEC based sensor. And they've pretty much taken over the OSEC project. And what they've done is they've wrapped a pretty nice Kibana interface around it. And it's really easy to build your own dashboards in. And that gets important in a minute when I show you some of the dashboards we kind of created. With this, the open source framework, it monitors things like file integrity, policy monitoring, and kind of vulnerability detection, incident response, all of those kind of things. It also integrates with some external services like VirusTotal and AWS. So I liked it for that kind of like flexibility at the time. But like I said, you could do something similar with OS Query if you want to. It's just this was all built together and it was pretty solid to use at the time. So how do we get those logs? All right, we want to make those pretty pictures. We know what logs we want to grab. So how do we get these guys? Well, I'm going to speak about this from the Wazoo AWS integration. And the reason for that is two reasons. One, it's already built, so it's not vaporware, it exists. And two, it's completely open source, so you can pillage it and use it for your own needs and use cases. Basically, what I'm going to be showing you is code that is freely available and tested working in production environments of thousands of systems. So it's reasonably reliable and tested at scale. They're all things that you can take away directly from today and implement, tomorrow into your environment if you really want to. It's that kind of stable. So here, what we use for the Wazoo agent is it's built in Python and it uses Boto 3. Boto 3 is the AWS CLI Python module, basically, and it allows you as a framework to interact with the AWS API directly, and it's pretty straightforward. The integration, it iterates over files, so that would be the things in the S3 buckets that we're storing, and it parses the file contents to get events. It sends the retrieved events to Wazoo, and then it raises an alert and shows it in Kibana. That's it. All right. If you wanted to use a different system, like just straight up Elastic Stack, it's the same process. You do it the exact same way. If you wanted to do it on, QRadar, Splunk, etc., exact same process, different API call for collecting the data and raising the alerts. But the gathering, the parsing, the iterating, all of it's the same. So how do we iterate over those files? Well, this is the section of the presentation that I understand at a conceptual level because I'm a terrible programmer. I know I'm a terrible programmer because I've seen my code and I've seen it in production, and I will not allow my code in production. So this is the part that Marta usually talks about and explains very well, and I am going to attempt to do the same. So let's start with the first step, the iterating over files. My approach to iterate over the files is shown in the slides. It calls to the list objects v2 function. It iterates over the returned file objects. So the simplified approach to this had several challenges that we had to do. Any of you who have ever tried parsing AWS logs know that they are not currently standardized. I know personally there is an initiative to standardize all the logs, and there are some formats there. I wrote some stuff to actually improve the format that they're moving to collect security data as well, so I know it's coming. But for right now, you're going to have to deal with properly formatted JSON, improperly formatted JSON, CSV, and a collection of mismatch between those three. So the simplified approach had that several challenge. How do you filter by region? Well, there's a couple of different things. Not all AWS services are global. Some of them are region specific. So that's one problem. Second one is an account. How do you filter by account? Because a lot of organizations have more than one AWS account. So if you have an instance or a service that is deployed in 3 regions across 10 accounts, that's 30 that you're going to have to record and log. There are some easier ways to do that now with things like CloudWatch event busing and other fancy stuff like that that allows you to send it all to one account, but not everybody is set up to do that. So if you don't have a really mature deployment of AWS where you're consolidating things to a single security account and the logging is going to there, you're going to have to deal with multiple regions and multiple accounts in your data. So that's one. So approach all the logs from all the regions and accounts to be processed. Next, if an old bucket is used, the script will start processing files from the very beginning. So in this case, we don't want to be constantly trying to ingest because that is going to lead to sad times. It's mostly like the argument between UDP and TCP, right? That's where you're playing catch with someone, and you throw the ball and walk away, and you don't care where it goes. That's UDP. That's what would happen if we sent the fire hose directly at Kibana and Wazoo. You would be dropping stuff. So we're going to use a pull method to do this. And what we'll need to do is we'll need to iterate over the log file, find out where the last processing occurred, and then continue on from there. So we're not constantly ingesting old logs and getting duplicates and adding all that processing time, because processing time equals money when you're renting CPU cycles in a cloud environment. Now, next up is we want to break this into sizable chunks. So we're going to try to only return 1,000 items at a time. For this, we need to paginate over several calls, and we want to fetch all the files. Now, as I was talking, what I should have done was actually highlight these sections of the code. But the list objects v2, this is where we're going to be controlling what object we're going to be interacting with, and then this bucket file content is kind of how we're doing that iteration. Now, the big issue that we ran into was filtering by account ID. So let's filter by these. A CloudTrail log path looks like this. All right, and in it we have a couple of attributes. It contains an account ID, a region name, and its date. With the information in the path name, we can directly ask S3 for those files that we're interested in, but if we want to put them into our SIM or ingest them in a more meaningful way, we're going to have to be able to parse out those names and iterate through them. So another approach would be to fetch all the items, filter results manually, but any work that we can delegate to the AWS server side, that something like having CloudWatch filter it or using the Boda 3 client to have AWS filter it saves us money, all right? Because they're not going to charge you extra for doing the running a request with filter options. But if you pull everything and then filter it on your server on AWS, you're paying for all that CPU cycle that you're using to parse that. So this is another way that we're saving money in the free lab, as well as shrinking our data set to just what we care about. In this case, what we're looking at is region name. So we're looking at that prefix. The argument prefix is used to filter path names based on how the path names are formatted. The output of the script above is shown in the second snippet, and we've been able to filter by account ID and region. So where are the logs from? Well, this is showing that these are old logs, right? They're from 2017. Do we want to still be ingesting them today over and over again? Probably not. So we want to use that as a filtering prefix as well. Now, one approach to filter by date is to leverage the prefix used by the filter, by the account ID and the region, and adding the data and everything that we want. But the approach would only return logs from the specified day and not from additional days. To solve this, we had to use an argument called start after. And what start after is doing is allowing us to specify the file name to start in and iterate all files after that. That really helps because of the standard file naming. We're able to not have to manually filter things over and over again and figure stuff out. We can do that all programmatically, and we can do that all at the server side to save us all that extra money from having to do it ourselves. So The next thing is we're going to look at the specific date breakdown. This is how we divvy things up. I like to chunk things by day normally. That's usually a reasonably sizable and ingestible amount of data. I try not to do any more than that or any larger than that just because it will end up costing a lot more money. So iterating over all the accounts and regions. So building on the solution, what if we want to process all the accounts and all regions in the bucket, but still filter by the date? To do this, we got to get the account IDs and, oops, that is totally not the button that should have been pressed. There we go. So what we're going to want to do is we're going to want to iterate over the common prefixes. And we want to delegate all the possible workload to the server to limit our input data set, save us money, process only what we want. So what we're doing next is we're going to use delimiter and the common prefixes, and that's going to break up the dates for us and the region names and the account name. It's basically going to give us all the information that we're going to use as our filtering conditions. So the path name here, originally they're grouped by file names by account and region. Amazon returns those group file names in the common prefixes. And in the second snippet, it shows examples of the how-to function. So these are just more ways that we're filtering in the code. Now, once we have the function to get all the accounts and regions, we just have to iterate over them. And that way we're filtering by date and letting the server do all the filtering for us. And once again, it's saving us that ton of money that I just don't like spending, because I would much rather use it for a better coffee maker in the office than, go to Amazon or whoever my provider is. Once we have a function to get all that and iterate all of it, we're just going to keep looping and looping and looping and try to catch all those logs. And we're going to be doing it in chunks of 1,000 at a time. And that's going to, there's a Python trick that Marta used that I don't fully understand. So I'm not going to try and explain it to you, but you can ask her a question afterwards of how it works. So these are a couple of the Python tricks she wants to highlight that they used. The dynamically defined argument and returning a default value if a key isn't found in the directory. So parsing file contents. That was a lot of like deep dive technical into the logging. And once we solve this problem, it's time to kind of parse those logs and get the file events. And logs can be decompressed before parsing. They can use gzip or zip or snappy. I had actually never heard of snappy before starting work with this, and I didn't even know it was an option for compressing data. It can even be uncompressed entirely. So each service uses different data structures. Firehose and CloudTrail logs are JSON and VPC flows CSV. Also, some of the services, as we mentioned, use specific log files, and they're improperly formatted JSON. So to manage all of these, the best implementation approach is to use the object-oriented programming. So all the common attributes and methods, they're kind of defined in the abstract class, and each service would have inherited all of that. So to make life a little bit easier, here is a working example in open source code. You can grab it, you can pop it in and use it. You can read the code over and understand it. That is probably the best thing that we can do. And don't copy off Stack Overflow. Use actual code. That'll lead to the problem that we're going to be talking about in the end-to-end example. Just a quick example of what the CloudTrail logs could look like. This is CloudTrail. It's a JSON file with a single records key. The key is an array of JSON objects where each object is an event to be processed. That is how it should be. That makes life really easy, that you can pull the stuff directly into any sim you want. Pretty much everything on the market has a JSON interpreter to pull logging into. Wonderful. Other times, things like Firehose logs, specifically, this is what guard duty logs used to look like. They no longer look like this. Now they are properly formatted JSON. It's just a lot of appended JSON objects. And as you can see in the screenshot, the file structure is not parsable with regular JSON parsers. And Python just ends up giving us decoder errors. So this is one of the things that we kept running into, trying to figure out why isn't this processing? It's real JSON. We looked at single events. The JSON's properly formatted. What the heck? Well, it wasn't properly structuring them when it got written through the fire hose. So something that you end up having to work with. Next up, we want to do mapping. Uh, I used to work at a company called Squirrel, and then AWS acquired us. Squirrel had a wonderful threat hunting platform that used a kind of data science model where things are broken into data sources with entities and features. So here, what we wanted to do is we wanted to graphically represent how we're going to correlate the data together. So we're taking things like the AWS region and mapping it to an account feature. This is very similar to how you want to do it in the SIM. You take those specific attributes and you map them together, and you're able to break them into even smaller attributes. Like for an account, you want to have the principal ID, you want to have the ARN, the account ID, the access key IDs, all the things that are associated. So you have your account and then all the attributes of it kind of around in your little mind map, right? So whenever you're doing queries and you need to pivot and you need to say who, well, it's the same thing as having three names. Ryan is just my first name, or in this case, that's a principal ID. If I want to have the ARN, the full name, that's, Ryan Nolette, that's my, legal name. And then I also have a middle name. So that could be your account ID. I have a driver's license and a social security number and all these other IDs that identify me as a single entity. That's what we're doing here with features. We have a single entity and every feature is an attribute of that entity. And that's kind of the logic going forward that we're going to do in the actual end-to-end. Now, for the end-to-end, one of the best parts about the end goal of ingesting all of this data and solving all these problems and answering questions is that I get to make pretty pictures. And these are dynamically updated pretty pictures. So a few simple dashboards, all these dashboards and more, they're including the Detonation Lab Kibana instance. So you can pull them out, revamp them for whatever you want, duplicate them, go crazy. But we're going to go with top destination addresses, top talkers by interface, most common account IDs and the guard duty alerts, and then the most common CloudTrail events, right? And why do we care about that? Well, unless I can define what's normal, I can't easily say what's abnormal in my environment. Right? This goes back to the sysadmin creed, know thy network, right? That's exactly what we want to do here. So with all this information and these cool dashboards, we also have a couple other ones that we included in. And this is going to be the beginning of the finding what matters section. So the end-to-end example of what happens when you put unsecured infrastructure on the internet and wait for something to happen. Here, what we did is we took VPC flow and CloudTrail data and a few other data sources, guard duty and things, and we created a geolocation map. So we did a world heat map just for the VPC flow traffic. We noticed that China is now the most common destination for anything in our environment. It's nice, bright red, not really unexpected. They have wonderful scanners. So what we noticed is that it's a common destination. So let's look at the histogram and see, the volume of data. Well, we noticed that there's a huge spike that occurs randomly within the data set. And when we look at the bottom of the histogram, we're able to see that it's a single IP address. So this single IP address is responsible for that huge spike in traffic that we had in our environment. This is not uncommon. Anybody that has any kind of IPS or monitors their perimeter firewall logs will see scanners hit it all day, every day from the same IP addresses, right? Usually people just drop the traffic from it, move on with their day because it's kind of low impact. But if you don't have that kind of security in depth, you're going to end up seeing like the traffic like this once people get in. So what we did is we took that IP address and we wanted to check our logs to see if any other events involving the destination are there. We find multiple guard duty events, all right? Multiple guard duty alerts for traffic to known CNC servers. So we can see that there's an SSH brute force attempt. against one of the servers and a few other attacks. And we can look at the involved instance for the culprit because we also have endpoint telemetry. So right now we've gone from VPC flow to our IDS. So let's call it the standard names, NetFlow to IDS to correlate those two. Then we're going to drop into endpoint telemetry, and we're going to have full stack analysis through our entire security stack, our entire visibility stack. So what we're going to check for is the same IP address. We know that this one host is communicating with this IP address. So we want to know what process is responsible for this. Now, I don't know about you, but I have no idea what version of Python people want to program on. I know a lot of people use Python 2. I also know it went end of life at the beginning of this year, and Python 3 is popular. But what version of Python 3 is common? Well, in this lab, we are not Python 3 compatible. Consider it legacy code. Anybody that has an enterprise knows what legacy apps are like, legacy support. Just about every large institution has an old XP server running some financial critical task, and it is quite scary to see. So one of the things that we're going to kind of look at is why is pip 3.7 talking to this network? Well, at the time of this event, pip 3.7 was not released. I Googled it, pip.3 did not exist. I think it was pip 3.2 something was the latest. So that immediately makes me go, what the hell is going on? Why is this in the environment if it does not exist? So we go and look at the file, and we can see when it was added, and it was recently added. We see that it's a new file, and what we can do is we grab the hash of it. In this case, the MD5. Not a lot of people use MD5 or SHA-1 anymore due to collisions. I agree. 256 is the way to go, but work with what's available. So we send that over using the virus total integration, and it tells us that we have a file installed in the system that has 53 out of 68 hits. I'm going to think that's probably something bad, and we probably don't want it in the environment anymore, right? So we go back through all the alerts, and we find out that the Apache user, as you can see up here, wrote a new file to disk, and Apache is not a normal user. So these are all attributes that are kind of those red flags firing up, and we're able to take something from that VPC flow and relate it to our alerting and bring it to our endpoint telemetry and see from the network connection what the actual file activity was, what processes were run, what files were created, what users did it, when it happened. So we're able to answer the who did what and when at the endpoint, at our security stack, at our network stack, and in our identity stack, all together giving us that full stack analysis of all the activity that's occurring in this cloud environment. So how did they get in? Well, like I said before, the Windows and Linux victim systems in there have vulnerable software installed on it on purpose. This to allow people to do attacks and kind of, it's not about teaching red teaming of how to get in. It's about blue teaming and purple teaming. It's about teaching people to find out how our attacker is going to get in. Therefore, I should poke at it and see whether or not that's a viable attack vector for them. So all I did was I ran a couple of open source tools, Nmap, Nessus, all that kind of stuff. And here, one of my favorite tools, Nikto, sees that we have something for directory transversal available to us. We go and we check out what the vulnerability is. We find out it's an old unpatched one and fairly severe. Basically, if you're able to exploit it, it gives you full remote code execution on the system. So with that simple scan, which we probably could have done with Inspector or Cassandra or Cassie or any of those vulnerability scanning tools that you're interested in, they would do something very similar and tell us that this vulnerability exists and we should patch it immediately. So to do a last recap, you know, I'm able to view all the activity in the cloud environment very similarly to how I would on-prem. I use the cloud native tools to increase the visibility until I'm able to find accountability for all the actions that are occurring. Using just tools available from AWS and open source, you can monitor your entire environment very effectively. Yes, some proprietary tools are going to do different jobs better because they're designed to do so and people are putting money behind them to do it. But even if you're on a shoestring budget, you can still maintain that level of visibility in your environment. And just for fun, going over the attackers, let's go over the attacker lifecycle real quick. So a lot of times we see people that started working hard, but not really seeing any financial returns to need to basically live the kind of life that they wanted, that quality of life. So they discover with a few investments, they can make money easy with crypto miners and some common for hire or for rent botnets. So next thing they do is they start deploying these out. They start making some money from the ill-gotten gains. They end up buying the only Lambo in Eastern Europe, which gets them arrested for tax evasion, which leads them to flipping as a witness and ending up in the Witness Protection Agency and starting the cycle all again. Thank you for your time today, guys. Remember my motto, flag it, tag it, and bag it. And if you guys have any questions, security related or AWS related, feel free. I'll stay on for as long as we're still chatting and everything. I also saw that my colleague Marta's on, so if you have programming questions, you can ask that. Feel free to open up feature requests on our GitHub project or just reach out to us over email. Thanks, guys.
Hey Ryan, it's Walt. This was a great session. Something you might want to think about integrating in because it will make the process of connecting this into other things that much easier is Apache NiFi.
Thank you.
Okay, thanks for raising that. Well, I saw it in the chat and was going to raise it if you didn't. Any questions, comments from other folks?
Hey Ryan, this is Jason. Thanks, this is a great session. One question for you is, this is terrific and I think easy, not easy, that's not a fair statement, straightforward for you to do because everything in AWS is by definition a set of microservices and enabled with APIs. And I wonder if you've seen anyone do this with on-premises tools because I think many of those are not going to be as rich in terms of either an API set or a way to be more easily integratable in terms of data flows.
Yes and no with that one. Yes, I have built this on premises. I've also built it in a hybrid environment that was on-prem and cloud as they were migrating. So a lot of the free tooling that I mentioned here is available, but also there's on-premises equivalents, right? We can't capture VPC flow on-prem, right? It just doesn't exist. So you need to capture net flow. So how do you capture net flow? You either use a span port off of your core router, which is free. You use a tap, which is expensive but very useful. Or you install something like Bro, which is free on the endpoints to collect that telemetry, which would be good for servers and things like that. But then you can also use something like OS Query to put on all of your endpoints, very lightweight. Companies like Uptick and Collide, I think those are both Boston local companies that are OS Query sensor based that provide a management suite around it. And that'll give you full network stack telemetry as well as process and file integrity monitoring, all those feature sets as well as operational queries. I can tell you as of right now, I have just completed an evaluation of EDR vendors. I included 35 vendors and scored them across 35 categories. And I can tell you the top 3 vendors, 2 of them are open source. And that's for visibility, ease of deployment, and management overhead for them. So depending on what kind of work you want to put into it, that's possible. As for what people have on-prem, I think the reality of making this happen really depends on what kind of tools you already have deployed and what kind of managerial and executive buy-in you have for implementing new tools and changing, those technical controls. The easiest way is to implement policy and then enforce it with a technical control to gain that visibility and to help protect the environment. Culture changes are hard, so I wish the best of luck with any of those.
Great,
So
thank you.
Ryan, you said you just did a research of all those EDR vendors. Is that research going to become public? And if so, how and when?
That's one of the things I've been debating. I basically did this for a previous company and I repeated it for my current company. And my biggest concern with publishing it would be the wrath of the vendors, because I did not evaluate them in their best light. I evaluated them in a very specific couple of use cases that are very specific to my needs. Windows was not even a concern, which most of the big name vendors are Windows first platforms, and then they bolt on things for like OS X and Linux. Linux focus was my primary concern, so a lot of the big name vendors, their offerings were lacking and not as mature in that space because that's not where they make their money. They make their money on Windows and Mac OS. So I'm a little worried about if I post that, what I'll have to deal with.
Okay. Other questions?
All right, awesome. In that case, I will stop sharing and stop recording. And nope, that says there it is.